Dear friends, today I will explain the theory of relativity in a simple and easy way for everyone. Get ready for a fascinating journey through time and space, where physics meets imagination. Before diving into the details of the two theories, it is essential to understand that relativity revolutionizes our way of seeing the universe. It shows us that time and space are not fixed, but flexible and variable. I formulated these theories at the beginning of the 20th century, inspired by some unresolved problems in physics of the time. Before relativity, physics was dominated by Isaac Newton's laws, which described space and time as separate and absolute entities. However, new experiments on electromagnetism and the speed of light showed results that could not be explained with classical physics. When we talk about relativity, we refer to two elaborated theories: special relativity and general relativity. The first deals with high velocities and states that the laws of physics are the same in all inertial reference frames. The second introduces gravity as a curvature of space-time caused by mass. Together, these two theories revolutionized our understanding of the universe. Imagine that Albert Einstein himself boards an airplane. Suppose the airplane can travel at a speed very close to the speed of light. On board the airplane, Einstein observes his pocket watch. For him, time seems to pass normally. The seconds tick by as usual. However, for an observer on Earth watching the airplane, things appear very different. Einstein's watch seems to move much more slowly. This is what we call time dilation. The faster the airplane accelerates, the slower time passes for Einstein compared to the observer on Earth. If the airplane could actually reach the speed of light, which according to current physical laws is impossible for an object with mass, time for Einstein on the airplane would stop entirely compared to the observer on Earth. So, when the airplane finally lands, Einstein might have experienced only a few minutes of flight, while years could have passed on Earth. This extraordinary thought shows us how flexible time is and how it depends on the speed at which we move. Through this imagination, we can begin to understand one of the fundamental concepts of the theory of special relativity. Time is not absolute but varies depending on the speed of movement relative to the observer. A vision that revolutionized the way we conceive of the universe. Now, imagine being in space, surrounded by stars and planets. The theory of general relativity says that space and time are intertwined in a single continuum called space-time. Now, imagine this space-time as a vast, stretched, elastic sheet. When you place a massive object on this sheet, like the sun, the fabric curves around it, creating a sort of depression. Other objects, like the planets in the solar system, are like marbles rolling on this sheet. If you roll a marble close to the sun, it will follow the curve and begin to orbit around it, just as the planets do around the sun. But there's more. Not only do masses curve space, but they also curve time. The closer you are to a massive object, the slower time passes compared to someone farther away. This is why astronauts traveling near large masses experience time differently than we do on Earth. Remember the movie Interstellar? The scene where they land on the planet near the black hole, and every hour they spend there equals 7 years on Earth?
There's one complication. The planet is much closer to Gargantua than we thought.
Gargantua. It's what we're calling them, the black hole. Miller's and Dr. Mann's planets both orbit it.
And Miller's is on the horizon?
Oh, it's a basketball around a hoop. Landing there takes us dangerously close, and a black hole that big has a huge gravitational pull.
Look, I could swing around that neutron star to decelerate.
No, it's not that. It's time. The gravity on that planet will slow our clock compared to Earth's drastically.
Oh, how bad?
Well, every hour we spend on that planet will be 7 years back on Earth.
That's general relativity in action. This theory not only explains the orbits of planets, but also phenomena like black holes, where the curvature of space-time is so extreme that nothing, not even light, can escape. This is the magic of general relativity, a cosmic dance of space, time, and gravity that keeps us all tied together in harmonious balance. My dear friends, I hope this narrative has fascinated you. If you want to continue exploring the mysteries of the universe together, don't forget to follow the channel for more incredible videos. There is so much more to discover, and I am here to accompany you on this cosmic journey.